Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
In this problem, we're given information about the components of a magnetic field, a vector, at a particular location. And then we're said that some wire of a particular length is oriented along one of our coordinate directions, and that wire is then going to carry a particular current. And so we just want to figure out what is the magnetic force acting on that particular wire. And really, we just want the magnitude of that force. So that's nice. One less thing to look at. So let's just get an idea of what this situation looks like. Let's draw a coordinate system. So we'll have our z direction heading this way. Let's put our x direction this way and our y direction along this way. So at this particular, say, location, we'll put it at the origin, we have information about the components of the magnetic field at that location, right? So we know that along the x-axis, we're going to have a magnetic field component along the x-axis that's given by, in this case, 0.1 teslas. We're going to have a component in the y direction that's given by, let's try to draw it a little longer, right? By 0.15 teslas. And then we have a component in the z direction, a little bit longer than that, just a tad. Bz is equal to 0.17 teslas. Okay, so that's the information about the components of the magnetic field. We're also told that there is a wire that runs along the z direction, say something like this. And it carries a current I in it. And that current is going to be, let's see, given as 4.3 amps. Cool. We also know that the wire has a particular length. We are given that length. Let me draw that a little better. I'll call that big L, and then it is 25 centimeters, so 0.25 meters. Okay, so if we remember information about the Lorentz force or the magnetic force on moving charges, because the current is heading along the z direction, right? The magnetic field component along the z direction will not contribute at all to the net magnetic force that this wire is going to feel. The only parts of the force that are going to cause, the only parts of the magnetic field that are going to cause any magnetic force on this wire are the parts that are perpendicular to the direction of the current in that wire. And so we see then that the only components of our magnetic field that are perpendicular to our current are the Bx and By components. They contribute to F mag. The magnetic force that's acting on this thing. So if we go back and look at our equation for the magnetic force that acts on a wire of length L, it's given by ILB times sine of phi, right? Where phi, again, is the angle between the current and the overall magnetic field. But we just said, right, that the magnetic field components we have left are perpendicular already to our current. So this is just going to go to 1. All of it is perpendicular. And we just need the magnitude of the overall force that's going to contribute to that. Well, if we look at that, right, the overall magnetic force, if we take our x component here, move it, x component of the magnetic field there, move it over there, we have a total magnetic field that contributes to the magnetic force like this, and you'll see that it's the y component and the x component magnetic field that make up the perpendicular part of the overall magnetic field that's going to contribute to the magnetic force. So if we want to find this magnitude of magnetic force that contributes to our magnetic field that contributes to the magnetic force, it's just going to be given by the squares of our x and y components added together, square rooted and added. So we know all the information. We know the current going through the wire, how long it is, and the x and y components of our magnetic field. And that's going to allow us to figure out the total magnetic force magnitude that is acting on this wire. So IL multiplied by the square root of bx squared plus by squared. Putting all this in, the current we're given is 4.3 amps. The length of our wire is 0.25 meters. And then we're going to take the square root of our 0.10, can't forget our units, Tesla squared, plus our 0.15 Teslas squared. Putting that all into our calculator, we see that we get a magnitude of the magnetic force acting on this wire is 0.19 newtons. And that is our answer.